Continuing with some geometric sequences, we've got I'm multiplying times 2. So if I'm going to write this recursively, I need to identify my first term, of course, is 4. And then f of x could be found by multiplying 2, my common difference, I'm sorry, in this case, my common ratio, times f of x minus 1. So very similar to the arithmetic form, except in this case, I'm going to be multiplying. So, and then my explicit form, the form for a geometric sequence is going to be f of x equals the original amount, x of 1, or n sub 1, times the common difference, or rather common ratio, we'll call it r, to the n minus 1 power. So this is where the exponent comes into play, because what we're doing is we're multiplying this original amount times a sequence of 2's. Okay, I'm multiplying 4 times 2 times 2 to get 16. I'm multiplying 4 times 2 times 2 times 2 to get 32. So that's where this exponent comes in, this repeated multiplication. So my first term is 4. My common ratio is 2, and it's always going to be n to the first power. So f of x equals 4 times 2 to the n to the n minus 1. Now there is a way, we won't worry about it too much if we use the 0th power or 0th term, the number prior to the 4 here, in which case we could express this a little bit differently, but this will suffice for now. This is acceptable. Okay, so here we've got f of 1 is 5. We've got the common ratio is times 3. And so we're going to do f of x equals the original amount, 5, times, the common difference. The common difference is 3 times f of x minus 1. So to find a term, we're going to take the previous term and multiply it times 3. That's what this is saying. Where does the sequence start? It starts at 5. F of 1 equals 5. Explicitly, f of x equals the first term times the common ratio, always raised to n to the first power. So f of x, I should say, yeah, f of n rather, if we're going to be consistent. F of x equals the first term, which is 5, times the common ratio, which is 3, and it's always going to be to the x minus 1 power or to the n minus 1 power, whichever variable we're going to use. Okay, I hope that helped. If not, then please just let me know. We'll arrange a time tomorrow to address your questions. All right, Carly? Have a good night.